Hey guys, welcome to our last section of 0.4, which is systems of two linear equations application problems. So what this means is we are actually applying linear systems to real world situations and solving them. So your learning target is I can write a system of equations to model and solve a real world problem. When using a system of equations to solve a problem, we follow the steps below. Now, these will help you on a test to know I'm looking for these 5 things when I give you a problem like this. The first thing you need to do is identify the unknowns. This will help you get started. Basically, what is the problem asking you to find? Second, once you've found those things or identified them, you assign a variable to each of them. Now, we like to use letters that make sense of the situation. For instance, if we were talking about dogs, number of dogs, I might use the variable D to represent the number of dogs. After we've done that, we will write 2 equations involving both variables using the information from the problem. Now, this is important because we have 2 variables, we're going to have 2 equations, and in each problem you should be given 2 different kind of sets of information, if you will, to help you write an equation. After you've written the 2 equations, you've solved the system using the method of your choice, and we can use substitution or elimination. Once we've solved, we answer the problem using a complete sentence. So that shows that we know what we solved for. Okay, let's go ahead and start with our examples. Write and solve a system of equations for each situation. Example A says the sum of 2 numbers is 85. Their difference is 11. Find the 2 numbers. So this one is pretty straightforward. I think we can all agree that what we're looking for, our unknowns, are the 2 numbers. Okay, so we're looking for these 2 numbers, so we need to assign variables to these 2 numbers. Now, these don't have really any descriptors other than that they're numbers. So I'm just going to use x and y. I'm going to say x equals our first number, and y equals our second number. Okay, so in our equations, we should have the variables x and y. Now I'm going to write 2 equations. So I'm going to go back to my problem, and I should be given 2 pieces of information that would each allow me to write an equation. So my first sentence is my first piece of information. The sum of the 2 numbers is 85. So my first equation is going to be related to this statement. Sum, remember, that's addition. So that means if I add the 2 numbers, I get 85. So my first equation, I'm going to write x plus y equals 85. Okay. The next sentence says their difference is 11. So remember, difference is subtraction. So I can write, and this is going to be for my second equation, x minus y equals 11. And that's our system. Now we're going to solve this system. Now I hope you notice that these are both in standard form, and look at right here. Our y's are already opposites of one another. So this definitely would be a good situation to use elimination. So I'm just going to write this over here just so we can see. I don't have to rewrite either of them because y's are already opposites of one another. So I'm going to make this a big addition problem. X plus x gives me 2x. My y's cancel. 85 plus 11 is 96. Divide by, oh gosh, that was not right. Divide by 2. And 96 divided by 2, don't feel like you can't use a calculator because you can. That's 48. Okay, so if x is 48, I need to go find y. So why don't I just go plug this 48 into either of the equations, I'm just going to plug it into the one that says x plus y equals 85. So x, oh, I know what x is, don't we? X is 48. So 48 plus y equals 85. So then I will just subtract 48, and I get y equals, just plug this in your calculator, 37. So there's not much to this problem to describe the answers. So it says answer using a complete sentence. So I'm just going to say one number is 48 and the other number is 37. And that is our first example.